check it out. All right, so this is where we left yesterday. We were about to say, we were reviewing at the end of yesterday. We said A, B, and C were just directly from our notes, right? I said y varies directly with x means this, and you guys did a good job of summarizing that. And then we started thinking about, hey, what could we branch out a little bit? Could we do ones crazy ones like D and E, where we have y varies inversely with the square of x? What? Tell me about that one. Did anyone think it through? Can anyone help me out? It's a little bit trickier, right? We have y varies inversely with the square of x. So that means this thing is equal to k divided by this thing, which is, instead of in words, we can write that as x squared. Yes, right? Is that clear? So this is a kind of a complicated relationship said in words, right? It varies inversely with x, with the square of x, or x squared.
Why don't they just say x squared? They put the square of x just sounds more complicated.
I don't know. What about the last one? This one's even trickier. Carlos knows, but he's not going to tell you quite yet because he doesn't want to spoil. He wants you to think about it for a second. This is tricky. We've got z varying directly with y and inversely with x. I mean, you haven't done ones like this, so maybe just take a
It's like both formulas.
It's kind of both formulas all in one, right? We kind of want. What do you think, Carlos? What was your take? You mean z equals?
Yeah,
Z. K, y. All right, so that's directly with y and over x. Yeah, is that cool? Do you like that? Can we do that? Absolutely. You don't need a second constant. The k absorbs all of the constants that you might have in there. So yeah, z has a direct relationship with y and an inverse relationship with x. And of course, we have to have that k in there somewhere. So you can put it on the top. You can even put it on the bottom. Doesn't matter. Okay. Is that cool? So can we? That's the idea. We're stepping out here. Now we didn't do any word problems really yesterday, so I thought I'd open with I'd show you a couple of word problems today too, and also some that will include some of these crazy ones. All right, see if you can handle some of these as well. That's the goal today. Does someone have a question? No. All right. This is going away in a second. Anyone still need it? 3, 2, 1. Catch it on the video. Okay, there you go. Joe, everybody. Give it up for Joe. Is paid an hourly wage. 1 week he worked. It's hard to know what that says, isn't it?
Wait,
40.
You just have one thing for each algebra class, or there's one algebra?
One. I recorded it.
Why did you choose this one? Did we ask the next question?
Why do you risk that?
I record this one because I like you guys better. No, I don't know. No one's going to watch this from my 6th period. We'll see. See if anyone calls us out on it. If anyone's in my 6th period, you get candy if you hear me. How's that?
The red and blue?
You get $100 if you. No, just kidding. It says it's recording. Okay, stop. Ask a question.
Oh my God, y'all are so slow.
All right, let's get back to Joe. Joe. Okay. He worked 43 hours. Let's first approach this without math. Marcelo, I need you.
Where's your line?
I know, sorry. Stop distracting me. 43 hours, and he got $795.50. Would you say to Joe, man, Joe, you're raking it in? Or would you say, well, which would you say? And can you quantify it mathematically?
Well, I made 0, so
what is his, I'm dying to know, what is his rate of pay? Aren't you dying to know? You're like, is he making more than I am? Okay, because I work at the bubble tea place, and he works at Joe's Sushi Shack. Yeah, Joe's Crab Shack. He works at the Crab Shack, and I want to know which one pays better. I work at summer. I'm a lifeguard. I make this much per hour. How much does he make per hour? Bubble tea lifeguard. Hybrid job. Very skilled labor. Tell me, somebody, I'm crying out for an answer to this question. How much does he make per hour? Forget the math or any of this stuff we've just been doing. He did tell you, kind of.
18.5.
You can solve all this problem faster.
Yeah, so why are you doing it?
Oh,
Huh? Do it, do it, do it. Oh, now we're finally doing it. Okay. This is not meant to be like a rocket science question.
What is it?
18.5.
She already said it. Yeah, yeah. But I just wanted you to come along for the ride, Logan. Okay. I was ignoring her because no one else was there with her. Okay. Yeah, yeah. So is that good? He's making what, $18.50 an hour? Is that good?
I want to make it. That's
I don't know.
half
It's not enough to like
price.
support a family, maybe, but it's decent, you know. Well, I don't know. Maybe it is.
I mean, double, yeah.
Yeah, it's definitely good if you're like a college kid or
Yeah,
something,
oh yeah, way good.
right?
Way good.
Yeah.
Yeah.
Okay. So I mean, it's decent wage. He's a hard-working man, Joe. Okay. All right. So yeah, good job. Keep up the work. Good work, Joe. If we wanted to frame this in terms of the stuff we've been doing, you could assign a variable to some of these things. The number of hours he works, let's let that be, what's your favorite letter? Hours, for hours he worked. H for hours, you could use T for time or something. So that's the number of hours he works. And what about why is this board shaking so much? Okay. What about what about his wages? What do you think? What would you like to have his wages be? W, or you could tell R for the rate what gets paid or something. A W for wages, or his wage per hour, his hourly wage. Okay, and then the total amount he gets paid for that many hours. What do you want to call that? I don't know. P for paid or T for total?
Z.
Z for what?
Irrelevant. T.
T for total. How about?
J for Joe.
Okay. Total amount that he makes. Okay. So what's the relationship, hopefully on any job that you work, ever, between H, W, and T?
H
What is
times W equals T.
Yeah, it should be true that the number of hours you work times the wages that you're paid equals the total amount of money you get, right? So when you did that division, a lot of you were like, oh yeah, we just do 795.5 divided by 43, right? What you're doing when you're doing that division is you're actually solving this problem, right? 795.50 equals W times 43, right? And when you divide, you get the wages. And the one thing I want you to see is that the units actually work out, don't they? What are the units of the wages that you get? What is it? 1850, right? What are the units associated with 1850? Dollars? Cents?
Dollar.
I'll tell you what they are.
Number.
It comes from this equation. This is measured in dollars, right? This is straight up dollars. This over here is straight up hours, right? Do you agree? So when you do this division, not only do you get 1850, but you also get dollars divided by hours, which is exactly the units you would expect to get, right? For your wages, okay? It's a rate of pay, dollars per hour. So just want to make sure that's all clear in our minds. Anyway, so Joe's equation, his magic equation is this, right? And how much does he earn per hour? He earns this amount per hour, okay? All right, ignore the boxes. Okay, don't look at that equation. Oh, no, that's good. All right, there we go. Because it's the one we're going to do. I have a bunch on here, and I'm not going to do them all. I'm just going to do the ones I started, because I started them for my sake, but know which ones I want to do. All right, this one, where's my candy box? I need candy on this one. Give me, I will give you a piece of candy. First person who tells me, with a K in it, give me the relationship right here. Stop at the period. You don't have to read any further than the period right there. R varies directly as the square of S. Tell me what you write down there, Carlos. Yeah, no numbers or anything, just with a K in it. What would it be?
How do you know what R and S is?
R equals
Is it R equals
Hey, guys.
R equals
Hey, Marcelo.
KS squared?
Say it one more time. Sorry, Marcelo was telling me.
R equals KS squared?
Yeah. R equals KS squared. Isn't that what that says? It says R varies directly as, so that means whatever equals something times whatever, right? So this thing equals K times this thing, right? Is that clear? So we're doing these crazy ones. So now we're not done yet. It says, you know, figure out what K is. If you do that, if I give you a sample value of R and S, what'd you get? K equals 3? Is that what you said? Here, have a piece of candy. You like sweet? You like chocolate? You like? So you got 3. Did you get 3 for K? 75. Here, we'll catch up with you here. 5 squared. All right, but we're not done yet, right? Right? We got to write the relationship, just like the warm-up today. R equals 3S squared. Boom. Plug in 5 for S, you'll get 75 for R. Questions, comments so far? Okay. Do you see how this works? Let's do another one. Someone else who hasn't gotten candy. First person to give me this first sentence with a K plugged in, an equation that relates A and B. Mitzi's got it.
Can you write it out?
B to the cube? Yeah. B to the third, or B cubed. Little peanut butter, you want peanut butter? I like peanut butter. Okay. Here we go. Yeah, what Mitzi said was A, this should be like similar to the last one. A equals K times B to the third, right? Right? So solve it now. What is K? If B and A have those values at a certain moment in time. Q? Because it says A varies directly as the cube of B. Yeah. K is 5. Is that right?
Oh, I just got it. K is 5.
Sorry.
Too slow.
Jonathan beats to it. Going for the shooting? Okay, all right. Strong choice. All right, here we go. What? How do you do that? You got 5? So you got 40 equals K times 2 cubed. All right, I feel you. Okay, that's good. Times 8, so that's 5 equals K. All right, and then our final answer, what's our equation? It's going to be A equals 5B cubed. That's pretty cool. And then actually, let's read the instructions because we haven't done that recently. Okay, did we do all the things that it asked? Write a formula to express the situation. Find the constant of proportionality. And actually, we've gone further. That's kind of A and B together, right? And then it also says, though, in C, we haven't answered C, but someone briefly answer C. What's the value of A if B is 1? No, I'm not going to give candy for this, but that's not quite right. What is it? If B is 1? It's just 5, right? 1 cubed is 1, and then times 5 is 5. So the answer to that question is A equals 5 if B is 1. All right? Moving smartly along. Yeah, we still got 10 minutes. Okay. Yeah, don't worry. Yeah, because you really want some candy. I can see it in your eyes. All right, this one's not interesting, but I wanted to put it in here because it's like has a physics flavor. I like, so the actual math is not super crazy. But we should talk about Hooke's law here for a second. Has anyone ever heard of Hooke's law? If you've taken physics or anything, you've maybe heard of it, yeah. Hooke's law relates a spring, that's the length of a spring, to the force that's applied on it. And for any given spring, every spring has something called a spring constant. And you know this because if you play with springs, certain springs behave differently than other springs. That's because they all have a different spring constant associated with them. So we have this particular spring in mind that we're playing with, okay? we should maybe get an equation, some variables first, right, before we go any further. We need to have a variable for the distance. I'm going to call that x. That is the distance that the spring stretches, right, that says. We'll call f the force that we apply it. And then we'll have some constant k. So what does it say? It says that the distance a spring stretches varies directly as the force applied. So x equals kf would be a fine way to write it. That's not the interesting part of this problem, right? I just want to make sure you understand the physics happening here. There's nothing they can teach you in physics that isn't just a consequence of math. That's all, right? Math governs everything. All right, anyway, so the interesting part is over. Plug in some stuff here. It says if a force of 15 is applied, 15 pounds, that stretches the spring 8 inches. That results in x being 8. If a force of 30 is applied, what does that mean for the length of that is, what is x going to be? That's the question. Okay? Ready, go. The first person to give it to me. Jesse has it. Oh, all right, got it.
Can you do like a speed round?
I just did.
No, like there's a whole bunch of problems.
I mean, I only have so much candy. I mean, like,
We have a whole box.
I barely make $18.50 an hour myself. Okay, so come on. All right. What do you think? Do you like what he said? 16? You can almost see that right here, maybe. I mean, we can solve it out here. What do we get? 8 equals k times 15. So what's k? Yeah, 8 over 15. And then our equation, right, is x equals 8 over 15 times f. So now, if we plug in 30, what do we get? X equals 8 over 15 times 30. Yeah, those cancel out. We get a 2. Then you just multiply and you get 16 inches. 30 pounds results in a stretch of 16 inches. Right? 30 pounds of force. Questions so far? We good? Like I said, the math there is not meant to be the groundbreaking. I just, you know, any chance we get to say something about physics, we like to. All right. Let's not do that one. All right, there we go. How about this one? I want a piece of candy on this one. That first sentence, again, is a little tricky. Can you give me an equation that involves a k? I want to hear it from someone who hasn't got candy.
So, is this, no, it's inverse, but, oh, never mind.
Oh, just because there's a z? I know.
B.
Greg's think he's going to throw in his answer. Well, you don't need any numbers yet. I just want a k in there. Well, I mean, like write down like just like when we start, we write like y equals kx or something like that. That's what I want. Like just something with no numbers. Don't read past the period. No. Logan.
Y equals k over the square root of
No. I'm not gonna give it to you. Well, anyone not have candy yet? Jocelyn, you don't have candy, right? Give it to me.
Y equals K over the.
No. All right, Jesse.
I know.
Go ahead.
It's y squared.
No.
Oh, all right.
Brianna. There you go. Z equals k over the square root of y. Right? Z equals k over the square root of y. Well, because it says, right, I want you to start thinking more globally about these ideas now, right? It says this thing varies inversely as this thing. So that means Z equals, this thing equals k over that thing, right? So z equals k over the square root of y. Cool. Does that make sense? Okay, don't marry yourself to all the letters, right? We can do any letters we want in any position. I want you to have like a higher level thinking on this. Cool, and we can, once we have that level of thinking, we can do this with all sorts of letters and all sorts of really crazy relationships. Okay. Find the constant of proportionality given that y and z are the sample values there. I'll put candy on that. First person give me the k value.
K equals 20.
There it is. Wait, what?
250.
No! I thought you were going to say it.
Oh my god, wait. 257.
Oh, no, Amanda. 24. Okay, good.
Rooted.
I believe in you, Greg. See, what did you say, 24? Let's prove that that's true. Z is 4 when y is 36. So that's 6 down there. So we get 24 for k. So our relationship is z equals 24 over the square root of y. Yay. And then it also says find the value of z when y is 64. So what would that be? No candy for this, but just tell me.
3.
All right. Don't give up. No. We still have 2 minutes. You don't know, Greg. This could be your moment. So far, so good, though? Can we do crazy stuff like this? I think we can. All right. Last one. First person to give me answer to the whole thing gets the candy, okay? Just one.
What's the candy box?
The whole candy box. No. You can read it with me here. It says, do you guys know anything about music? Okay, because math rules that too. You like music? I like this one too because it's not tricky. It's not like really crazy, but it is interesting. You know that long strings, short strings, which ones produce low and which ones produce high notes?
High is long, low is short.
Yeah.
Well, no. Think about it's the opposite.
No.
They vary inversely, right? Actually, that's what this whole thing is. Like think about where the long strings are on the piano. Think about great. Think about it. I know there are other things involved, but also the tension on the strings,
Yeah,
right?
that's what I was
But if they had the same tension, think about a piano. Where are all the long strings on a piano? They're down at the low notes, right?
Oh, but I thought I was thinking about like violin.
You're right. I mean, you might think, well, they're all the same length on the guitar or something, but they all produce different pitches. They are the same length. Yeah, they are.
Some are like at the top.
So they're like a little bit, because it's angled a little bit or something. But they're basically the same length on guitars, pretty much. So how do they produce? But the thickness and the tension is what produces. So that's another relationship altogether. What'd you get? No. What'd you get? No. All right. No. Oh no, it is 100. You're right. Sorry. You're right.
Wait, how can I have a question?
100 is, what are the units? It is 100. I know, but that's how you got it first. 100 cycles per second, or 100 hertz. All right, bye guys. I know you got to go. Did everyone copy down the homework?